Alright, here is the review guide. I'm going to work this pretty quickly, but you'll be able to pause it and look back. Also, I will post just the answers that's not a video. Okay, so I would probably try all the problems first, then check my answers, and then if I didn't get some right, I would go in and look at this video. It would probably be the process. So here we just have to take this polynomial and put it in standard form. Remember, standard form is highest degree first. So the original polynomial, 2x times 5x plus 3 times 2x minus 4. You could multiply and distribute the 2x first if you wanted to, but I always like to do this distributing first, get rid of my binomials and multiply those together. So we distribute the 5x to both of the terms in the other binomial. That gives us 10x squared minus 20x. Next, we're going to distribute the 3 to both of those terms, and we get plus 6x minus 12. Okay, and we still haven't done anything with the 2x. Now, inside of this big, long polynomial, we've got some like terms right here in the middle. So we're going to add those up. So now it becomes 2x times, and we have our 10x squared. We combine the like terms, negative 20 plus 6, and then minus 12. And then lastly, we distribute the 2x to each of the three terms, giving us 20x cubed minus 28, 2 times 14, x squared, minus 2 times 12, and an x. And there it is in standard form. So that's your final answer. Then it says to classify it by degree and number of terms. Well, to get the degree, we look at the first exponent because we're in standard form. So this is cubic. And then to get the next part, the number of terms, we just count number of terms, and there's 3 of them. So that is a trinomial. Some of the other names we have to know: monomial, 1 term; binomial, 2; trinomial, 3. After 3 terms, it becomes a polynomial. The by degree part, linear if it's first degree, quadratic if it's degree 2 up here, cubic, quartic if it's degree 4, and quintic if it's degree 5. Okay, find the cubic polynomial to model the data. Let x equal years after 1940. So when you're setting up your table, and we do this in our calculator, your x values are going to be 0, 10, 20, 30, 40, 50, and this looks like it's going to be 59. Okay, that lets x be the years after 1940, so 1940 is 0 years after 1940. And you use your calculator. Remember, you go to Stat, edit your list 1 and your list 2. X is going list 1. And when you get done, you're going to tell your calculator to do a cubic regression, and it's going to tell you the equation for the cubic model that best fits this data. Okay, I'm not doing it on my calculator right now. I've already done it there, and this is what I came up with. Okay, remember how we do that on our calculators. We pull up cube reg, or CUB reg, I'm not sure which one it is. We tell it where our X list is and our Y list is. They're in L1 and L2, and then we tell it to save it to Y1 under variables. And then if you look underneath Y1 in the blue button top left, it should put this equation in there for you. Okay? And it should graph that equation if you needed to see the graph. So in this case, X is number of years since 1940, and the amount, Social Security benefits, is the Y value. So if you had a date since 1940, you could plug that into the equation for X, and it would tell you what the amount of benefits are, the Y value. In this case, they say 2010, so that is 70 years since 1940, so you have to plug in a 70 into all of the X spots. So it's a simple substitution. Let's see if I have an answer for that. I do not have an answer for that, so I'll let you work that out. On your calculators, remember what you can do, though, is once you have your equation stored in Y1 here, is you can tell your calculator what is the value of y1 if I plug in 70 for x, and it will automatically plug it in and evaluate it for you. Okay, part B, use your equation to determine the amount. Ooh, I just did that one, so we can check that off. Double check, yep. So we're on to problem 3. Oh, real quick, on this one right here, number 2, if you go to the website and look at my videos, I do have a video showing the calculator and how to enter data and how to do a linear regression, but the steps are very similar for a cubic regression, so that is online as well. Okay, we have to use our graphing calculator to solve these. I should probably show a video for this one too. I will tell you the answers, and then you can see if you can get those on your calculators. This one looks like it should have 4 answers, and the answers I get to the nearest hundredths are 0.707, negative 0.707, positive 2, and negative 2. We would generally write these things in a condensed form, like that. Okay, still 4 solutions. Part B here, again, we throw it into our graphing calculator and round to the nearest decimal where necessary. Well, I'm going to pause, and I'll be right back after I figure that out, hopefully. Alright, I quickly threw this one into my calculator after I set it equal to 0. Actually, I did one thing before that. As soon as I threw the 9x over and it became negative 9x, I noticed right away each of these terms has an x in it, which means I can use GCF and make it quadratic. But if you graph it, what you're going to find is this equation only crosses the x-axis in one spot. And I'll show that to you here in a second. I'm going to take out the GCF, which is 3 in this case. 3x, and so it's 12x squared plus 2x minus 3 equals 0. So we've just taken out the GCF of 3x. Now I've got it factored, and that 3x gives me one solution. That tells me x equals 0 is one of the answers, or one of the zeros of that polynomial. So it only has 2 left. Those 2 are hidden inside this quadratic. You could try and graph that quadratic and see if you can estimate the solutions. But so far, we would have seen that when we did it, graph the original equation. It's going to work. So if we can't use our calculator and we have a quadratic, I'm going to write it up here, we're simply going to throw this into the quadratic formula. So we go x equals, we'll do the opposite of b, plus or minus the square root of b squared, 2 squared is 4, minus 4 times a times c, all over 2 times a, which is 2 times 12, or 24. Okay, we're going to clean this up a little bit. That's negative 2 plus or minus our radicand. The stuff underneath the radical comes out to negative 140, I believe. No, I don't believe that's what it comes out to be. Because if I work on just the radicand, that's 4, it's going to be plus, because of these double negatives right here. It's going to be 4 times 4 is, or 3 times 4 is 12, so it's 12 times 12 plus 144. So I'm getting a positive 148 over 24. Well, I didn't really graph this previously. I just noticed that x was our GCF. And your calculator actually will give you decimal approximations for this. So once again, I'll pause it and this time really graph it. My calculator did give me the answers. I get negative 0.59 into the nearest hundredth 0. That's for the 0 on the left-hand side of the graph. And then for my 0, again, I'm doing second, calculate, find my 0. And the 0 on the right-hand side, it's going to be a positive 0. It says it is 0.424. Okay. Now I didn't really need my calculator for that at that point, or to do it that way. You could have also, using the quadratic formula, punched this in. You would do the plus sign first. That would give you the positive root, the positive 0.2424. And then you could have done the negative 2 minus root 148 divided by 24. And that would give you the negative solution. So we have three answers for this: the negative 0.590, the 0.424, and then the 0 out front.